Okay, thank you. And I'll have to really say thank you, Aaron, for giving this short introduction to what ontologies are. I was quite nervous to give this presentation for people who don't know anything. And thank you for giving the abbreviation of Web Ontology language, because now you see why BOT is called BOT, for Building Topology Ontology. A little about me. I have a master's degree from the Technical University of Denmark in architectural engineering. Since 2013, I've been working as an HVAC engineer in a consulting company now called Neros, because we just merged. 2,100 employees, and we have offices in 27 countries. Since January last year, I've been doing this industrial PhD, which is a partnership between the company and the university. So that's where I'm at. Short disposition. First I'm going to talk about the challenge that I'm trying to solve. Afterwards a bit about how we can use this distributed knowledge. Then the ontology that we're proposing. And then how you can extend it, some methods for that, and some final words. So first of all, the challenge. So I think we've seen that before several times today actually. Same data, different interpretations. So if I ask you, what do you see in this picture? If I asked an architect, he would say, I see some different office types. One of them for one person, one for two persons, one of them is a copy room. If I ask an indoor climate engineer what he sees some heat losses, some heat gains, equipment loads, schedules for people occupying the rooms. If I ask an automation engineer what he sees, he would see something like 2 control zones here. He has some controlled devices. He has a set point temperature that he should reach. He has an actuator and a temperature sensor. He also sees another zone, the heat circulation system. And if we ask the HVAC engineer, which is me, I basically just see some radiators that I need to give a certain size, dependent on the requirements from the indoor climate engineer. And I care about flow velocities and pressure drops and stuff like that. So it's the exact same 3D geometry we see here, but it's really, really different what interpretations we have of what we see. And how about if we ask the fire engineer, the tenant, the facility manager, the end user? The thing is that the tools we have today don't solve this problem. Okay, so this distributed knowledge. What we claim is that it should be up to the domain specialists to describe the domain knowledge. So if you look at this graphic I have here, you have several different domains here, all very specific and all working in the AEC industry. But what is common for them is that no matter what they describe, if it's just some sensor, they will always need to see their components in the context of a building. And that's why I'm showing this. So what we did was, okay, we said this will always be important to describe this. So we reviewed some existing ontologies. Aaron was also around this, that a lot of different domain ontologies exist out there. We have the very high purpose ones like DBpedia, which is basically a database version of Wikipedia that you can do queries on. Then you have the ones in the AEC industry, IFC-OWL, you've heard about that several times. Then we have something in smart cities, smart homes, etc. And what you see to the right here is that they all redundantly describe the same thing. They describe a building, they describe a story, a room, and some elements. And that's not really a problem because you can align these ontologies. That's possible with the ontology languages we have. You can use web ontology language to say, okay, I have a building in ontology A, and that's the same as building in ontology B. But if we have a lot of different domain ontologies, this is going to be very cumbersome to do all these alignments. So what we suggest is that there's something missing in between to link these in a convenient way. And that brings us to the building topology ontology. Whereas IFC has 1,580 classes, some of them describing parts of a building, some of them describing something with economy, some of them describing what a unit is, which is also described in other ontologies already existing. We're down to 4 classes, a building, a story, a space, and an element, and then we have these 5 relationships. has story, has space, and then a space can either contain an element or it can be surrounded by elements, so have adjacent elements. And if an element is located in a space that is on a story, then the story also has the element. That's basically the logics involved. So again, if we distinguish between the data layer and the terminology layer, the ontology layer on top, we have these rules describing, so if I have something that has a story, and that something has a space, and that something contains an element, then with bot, we can just infer that the first thing, that's a building, that's a story, that's a space, that's an element, and these has elements gets inferred automatically. So all these dashed lines you see is what is just based on the knowledge we have. Okay, so as you see, bot alone is not really worth anything when we need to describe a whole building. So of course we need a bunch of different domain ontologies that extend the bot. There are some different methods for doing this. One of them is defining subclasses. So you can see I use these prefixes bot : element. That means that this is part of bot, the bot ontology. So now say I want to describe an H heater. So I'm making a heating ontology, and I have that one. So if my something is an H heater, and that H heater is a subclass of element, then my something is also a bot element. So that's how that works. On the other hand, it doesn't mean that if I have a space that contains an element, then I automatically infer that it will be a heater. That would be wrong to say. What I could say though was that, okay, then I make another relationship that I call heated by, and I make that a subclass of the bot contains element. So now my space, instead of being containing an element, it is heated by something. And if I say that the range of that is the H heater, then I automatically infer that, okay, if it's heated by something, then it also contains that something, and then that something is a heater, and it's also a bot element. Then there is this other equivalent class approach to it. So say, for instance, I want to make a geography ontology, where I also have a building, which is a subclass of my geography spatial element. As soon as I say that geobuilding is the same as bot building, when that something I have is a bot building, it's automatically inferred that it's also a geobuilding and it's also a spatial element. And in that A3 poster, I also have this graphic where you can see all the orange up in the very left describe an ontology for the geography. The red is for that heater ontology, and then I also added the blue one up in the very right with IFC owl. But what you see down in my data set is that all I have is actually static type links between the different components, and everything else just gets inferred. So all the different classes are just inferred. Because I have something that, that has a location, then that something is a location, and that something is a building and story, and etc. Yeah, but since we're short on time, it's good that I'm fast here. Okay, we have some ongoing work here. We have a community group in the W3 Consortium where bot is currently being developed. So we're trying to implement this as a standard for sharing information about buildings on the web. And of course, there's room for improvement. Should bot include the site? Should we have connections between the rooms? So there could, for instance, be a direct connection between two rooms, or sharing a wall, or should we have indirect connections between rooms sharing a door? Should we have more of a transitive relationship property where you can say, okay, the space is also contained inside the building since it's located on a floor and stuff like that. But this is a first suggestion of something simple. The working groups we have, the community group is divided into some ontology working groups. Some of the people are present here today. Some work with geometry, some work with HVAC products, energy efficiency, automation and control, and project management. And we try to align all this stuff so that we get a complete ontology. Because that's the thing, is it's distributed data. It's possible for us to have a little here and there, and then use it as we wish. Future work, of course, is to see some software implementations of this. I'm building a RESTful API myself right now that communicates with the knowledge base. And we also need to see some other use cases, but I hope we'll see that in the near future. So just to summarize everything, bots only describes the relationships a certain component or anything may have to a building's topology. That's the purpose of bot. Then we have domain ontologies that describe domain knowledge. And we think that smaller, simpler ontologies makes it easier to use instead of having one large. That's also one of the rules of thumb when you push ontologies online. And then this thing that we can have distributed knowledge models with this technology. Yeah, that was basically it.
So we have time for
Yeah.